Good afternoon, dear students. Today we will be um, discussing areas of parallelograms and triangles. This is in continuation of whatever we have discussed in the previous class. Today we will start discussing the triangles on the same base and between the same parallels. Now, before I proceed further, please confirm that you are able to view the screen properly and able to hear my voice very clearly, dear students.
Yes,
Yes,
sir.
sir.
Okay, great. So, let us understand what is meant by the triangles on the same base and between the same parallels. So, for that, let us consider this, adjoining diagram. And as you see, that there are two triangles here. One is the triangle ABC and the other one is the triangle PBC. So, and both are having the same base BC and they are between the same parallels BC and AP. Correct, dear students? I hope you all of you are able to get it clearly. If you see that ABC, this is one triangle, these are the three vertices, and PBC, that uh, these are the three vertices at P, B, and C point. And as you see that if you join that points A and P, you get the line segment AP, and that line segment AP is parallel to BC, the common base. Hence, we can say that these two triangles ABC and PBC are on the same base BC and between the same parallels AP and BC. Correct, dear students? Now, what we are going to discuss? We are going to discuss that what we can say about the areas of these two triangles ABC and PBC. To answer this question, we need to perform some drawing, and then we can prove it. But before proof, you can experiment also. Suppose you can take uh, a paper, or you can take a graph sheet, okay, and draw two parallels lines, and then make the common base and draw multiple triangles on the same base and between the same parallels. Once you find it, then you can find the areas of these triangles. You have the graph paper. You can apply the formula of finding the area of a triangle, half into base into altitude. Okay, so that you can find it out, and then you'll see that areas of all these triangles are actually remain the same. Approximately you will find they are same. Okay. Now the thing is that why I'm saying approximately, because whenever you do the calculation, there could be some kind of a approximation, small error during the calculation. Small error means is that the errors which you can actually nullify, which you can ignore. Now the point is that how we can prove it. The question is that to prove it. So there are multiple ways you can prove it. And the first method, what we are going to uh, you know is that by means of some construction. But before doing the construction, what we just said a few minutes back is that the areas of triangles, okay, between the uh, areas of triangles on the same base and between the same parallels are equal. And we are going to prove it. And how to prove it? So that I'm going to show you now. But before proving it, let me write down that statement. Two triangles on the same base or equal base, we can say. So what we can write? Two triangles two triangles on the same base or you can say write is that or equal base and between the same parallels and between the same parallels okay are equal in area. So what does it mean by dear students is that if you look into these two triangles that ABC and PBC, they are on the same base BC and between the same parallels AP and BC. Hence, the areas of these two triangles ABC and PBC are same. Now, what we are going to do, we are going to prove it how they are equal, and to prove it, we need to make some construction. Okay, what is that construction that I'm going to show it to you now, dear students, and after that I will prove it. So let me first draw the diagram. So what about the diagram I have drawn earlier? So I'm just make a small, changes here. Means changes in the sense extra drawing I have made it here. So what was the triangles we were discussing, dear students? One is that ABC. So this is ABC, and the other one is that PBC. Correct, PBC. So we are taking, dear students, that that D and R are 2 points on the line segment AB such that CD is parallel to BA and CR is parallel to BP. So, and D and R are lie on the line segment AP. So what is the drawing? If I write it in the different color. So let me write down the drawing first. So drawing here is that CD is parallel to BA. CD is parallel to BA and CR is parallel to BP such that D and R lie on the line segment AP such that I can write it down such that D and R lie on the line AP. Now, how to prove it? Let us consider, dear students, that two parallelograms. The first parallelogram is PBCR and the second parallelogram ABCD. Can you say what is the area of these two parallelograms? Can you say some relationship of the areas of these two parallelograms, dear students? As you see, there are two parallelograms. One is PBCR and the parallelograms ABCD. Can you say about the relationship between the areas of these two parallelograms?
Sir, are they equal?
Both are equal
Yes, both are equal. Why both are equal? What
because
is
they are
the
lying on the same base between the same parallels.
fantastic? Absolutely. That is the right justification, right explanation. Okay, yes. These two parallelograms, the first one is PBCR and the second one is ABCD. They are of equal areas because they are on the same base BC and between the same parallels BC and AR. Okay, so what we see is that, so from this we obtained two parallelograms PBCR and ABCD. So let me write it down whatever I just said and we get something like this. I hope all of you agree to me. Correct? So we found that areas of these two parallelograms ABCD and PBCR are equal. Now let us concentrate on that parallelograms ABCD. And if you see the parallelograms ABCD, that means these parallelograms, if I just overlay with this thing, that this is ABCD, this parallelogram, if you look into it and you see that AC is the diagonal, can you say something about these two triangles? The first triangle is ABC and second triangle is CDA.
They are congruent.
Fantastic. They are congruent. Okay, why they are congruent? Because we know the diagonals of the parallelograms, divides the parallelogram into two congruent triangles. Fantastic answer. In the similar manner, if you look into the parallelogram PBCR, and if I use a different color, dear students, if we see that PB and this parallelogram, this parallelogram, then also you'll find there, and there is a diagonal is PC. Then what we get? Two triangles. One is PBC and another one is that CRP. Okay, so this is the diagonal, correct, dear students? So what we see is that these two triangles, PBC and CRP, they are also congruent to each other, correct? Clear or not clear?
Yes, sir.
Okay, so as they are congruent to each other, so I just want to write it down, all these things. So what we are going to get, dear students? So we get that these two triangles, that ABC CDA and PBC CRP, they are also congruent to each other. So let me write it down. So as they are congruent to each other, so what we can say, dear students? We can say that their areas should also be equal. But before that, what I'm going to say is that means area of the triangle ABC is equal to the area of the triangle CDA. Area of the triangle PBC is equal to area of the triangle CRP. That we know because they are congruent. But what we are going to say is that, could you please tell me what is the relationship between the triangle, area of the triangle ABC and area of the triangle ABCD? Can you please tell? Can someone please tell? One triangle is ABC and one parallelogram is ABCD. What is the relationship among them?
The area of ABC is equal to half of the parallelogram ABCD.
Absolutely. Absolutely. Srivali, do you agree to this?
Yes, sir. Yes, sir.
Yeah, because we know in the last session we discussed that when when a triangle and a parallelogram are on the same base and between the same parallels, then the area of the triangle is equal to the half of the area of the parallelogram, correct? So keeping this in mind, what we can say, dear students, we can say that area of the triangle ABC is equal to half of the area of the parallelogram ABCD, and area of the triangle PBC is equal to half of the area of the parallelogram PBCR. I repeat once more. So area of the triangle ABC is equal to half of the area of the parallelogram ABCD, and area of the triangle PBC is equal to half of the area of the triangle PBCR. Now we learned that area of the parallelogram ABCD is equal to area of the parallelogram PBCR, correct? As you see it here, we already proved it, no?
Yes, sir.
So from there, what we can say? From there, we can say that area of the triangle ABC is equal to the area of the triangle PBC, correct? And that proves whatever the statement initially we wrote in the red color. The two triangles on the same base and between the same parallels are equal in area. We are able to prove it, correct, dear students? Able to get it? Absolutely clear?
Yes, sir.
Okay. So we are able to prove it that just a minute. Okay. And also one thing you can notice is that we prove about the two triangles, but from a very practical point of view, if we draw two parallel lines, let us draw two parallel lines. Okay, so I'm just describing as we understood this theorem. I'm just going to discuss something more related to this. So what I'm doing, dear students, is that we are drawing two parallel lines. So let me draw two parallel lines. This is one parallel one line, and parallel to this line is this one. Okay, suppose we name it. One is AB and another one is a CD. So the line AB is parallel to CD. Now, what we are doing, dear students, from that line segment AB, we are taking a part of that one. What is that part? Let me draw it in the green color. So this is one point, and this is one point. And we are going to draw multiple, triangles. Now, point is that, suppose I say this is PQ, and if I draw on that blue line, so it is something like this, as you see, dear students. So this is the one, PQ is the one base of the triangle. Now we are going to draw multiple triangles, and the third vertex, dear students, so third vertex will be on the line segment CD. That means what? That means if I keep it, if I do in a different color, so one vertex will be here, 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 another vertex will be here. Suppose. So as I have pointed 5 such points on the line segment CD, so we are going to get 5 different triangles, and let me construct those triangles. The first one is this one. Just a minute. This is one triangle, right, dear students? And let me, just a minute, let me draw properly. So suppose this is R1. So one triangle we get PQR1. Now the next one I'm going to draw in a different color, and suppose that I'm going to draw in this yellow color. So okay, the second one, as you see, dear students, that is the point is R2. So another triangle is what? R2PQ. The third triangle that I'm going to draw in a different color. Suppose I draw in the purple color, and if you see this triangle, so this is, I say, R3, and the next one is, suppose.
Good afternoon, sir. What are you doing?
Oh, okay. Hi, Manishika. So we just we started few minutes back. So we were discussing. We just prove one theorem. Is that the two triangles on the same base and between the same parallels are equal in areas. Okay.
Okay, sir.
So there are two triangles in the adjoining diagram. One is ABC and another one is the PBC. So these two triangles are on the same base BC and between the same parallels AP and BC. And we proved a few minutes back that the areas of these two triangles are equal. After the class, you can look into the video lectures of the entire session, and you'll understand that why they are equal. Okay, the
Yes,
proof
sir.
I have been done it here. In all these these lines, I made a proof that why they are equal. Okay, so that you can look
Yes.
into it. So now I'm just discussing based on that. So we took two parallel lines. One is AB and another one is CD. And we took a common base PQ on that line segment AB, and on that line segment CD we placed 5 different points. So R1, R2, R3. So then we get one triangle called R1PQ, another triangle is R2PQ, another triangle is R3PQ. So now I'm going to draw the other two triangles. Okay, is it clear?
Yes, sir. Yes, sir.
Okay, great. So R4. So if I draw that, the triangle R4, I'm just joining this R4PQ, and
Sir, can there be more than 5?
You can have infinite number of triangles.
Yes,
I just, for the sake of our discussion, I took 5.
Okay, sir.
There is no other logic that why I took 5. It can be any number.
Okay,
Okay.
sir.
So this is R5. There is a reason why I'm saying so. Okay, that why I took 5 such. It could be 4, it could be 3, it could be 6. That doesn't matter. But you see that these two, the orientation of all these triangles are different, right? So if you see there, what are the different triangles we get? R1PQ, R2PQ, R3PQ, R4PQ, R5PQ, correct? Now, so the triangles are, let me write down the triangles here. So it is, let me use a different color. So the first triangle is R1PQ, second triangle is R2PQ, third triangle is R3PQ, fourth triangle is R4PQ, and the fifth one is R5PQ. Now, from the theorem, what we just proved, that we can say that okay, areas of all these triangles are what? Could you please complete the statement? Areas of all these triangles are
Equal.
equal. Exactly. That's the and the theorem says. A theorem says about two triangles. Now you can take first R1PQ and R2PQ, prove they are equal. Then you take two triangles, R2PQ and R3PQ, you prove they are equal. Then R1PQ and R3PQ also equal, no? If area of the triangle R1PQ is equal to area of the triangle R2PQ, and area of the triangle R2PQ is equal to area of the triangle R3PQ, then you can say, no, area of the triangle R1PQ is equal to the area of the triangle R3PQ. Correct, dear students?
Yes, sir.
Now, apart from the theorem, we are just applying the area of a triangle. What is area of a triangle? So all these areas hop into base. All their base are same, na PQ. Correct?
Yes, sir.
Their bases are same, PQ, right? So if I find the areas of these triangles, so what is the area? Their area, sorry, let me write properly. Their area is equal to what? Hop into base. Base is PQ into the altitude. If you look into the altitude, what is altitude for all these triangles? From the vertex, that is the vertex means R1, R2, R3, R4, R5, you draw a perpendicular to the base, correct or not? It may come directly to the base or it can come to the extended base, correct or not? For example, if I draw a perpendicular, so let me draw all the perpendicular in black color, for example. Okay, so if I draw a perpendicular from R5 to PQ, so it will be like this, na? Correct or not? From R4 to PQ, it will be like this. All of you agree to me? From R3 to PQ, it will be like this, correct?
Yes,
From
sir.
R2 to PQ, it will be like this.
Yes, sir.
And from R1 to PQ, it should be like this, correct or not? Now, whatever all the vertical lines I have drawn in black color, their length are equal to each other, right? Correct or not? So if I take the foot of this perpendicular on the line segment AB, as suppose it is L5, it is L4, it is L3, it is L2, and it is L1. Then I hope you agree to me that R1 L1 is equal to R2 L2 is equal to R3 L3 is equal to R4 L4 is equal to R5 L5. Correct, dear students?
Yes,
Because
sir.
it is the same, perpendicular line segment between two parallel lines. They have to be equal. Now, if you find the area of the triangle R1 PQ, it is half into PQ into R1 L1. Correct or not? Clear or not clear?
Yes, sir.
So, if I just write in a more elaborative manner, so what I wanted to say is that what I wanted to actually explain is that let us find their areas. Okay, so I can write something like this, that areas of so this triangle will be what? Half into PQ into R1 L1. Correct or not? Do you agree
Yes,
to me?
yes, sir.
That is equal to half into PQ into R2 L2. That is equal to half into PQ into R3 L3. That is equal to half into PQ into R4 L4. That is equal to half into PQ into R5 L5. Correct? Clear or not clear? Now, if you see, all these areas are equal because PQ are common and R1 N1 equal to R2 L2 equal to R3 L3 equal to R4 L4 equal to R5 L5. Correct? So all are equal. Do you agree to me?
Yes, sir.
All are.
Yes, sir.
So this is another way of looking into it, just applying our fundamental knowledge of areas of a area of a triangle, that half into base into altitude. So now, dear students, so before I proceed, what I say is that I just recap once more that if we have multiple triangles on the same base or equal base, I didn't emphasize on the equal base, I'll come after some time. So if we have multiple triangles on the same base and between the same parallels, then areas of all these triangles are equal to each other. Now let me focus on that equal base. You see, dear students, so there is a statement called equal base that I have written here, or equal base. What is meant by the equal base? Equal base mean by, you know what, dear students, is that maybe we have that the line segment PQ is not all these triangles are having the same base PQ. Maybe someone has having base P1 Q1, someone is having base P2 Q2, P2 Q2, someone is having the base P3 Q3, in that way. But all these line segments are of the equal length. So let me give you an example so that it will be more clear. Okay. So like the previous one, so let me first draw, two parallel lines. The first one is AB and the second one is CD. Now, dear students, if you look into it, that what I'm going to do, that I'm going to take three such points here. Okay. So one point is that suppose P1 Q1. Another one is that suppose P2 Q2. And another one I'm making like this thing P3 Q3. So this is P1 Q1. This is P2 Q2. And this is P3 Q3. So what is the condition? P1 Q1 is equal to P2 Q2 is equal to P3 Q3. Means they are on the equal base. Got my point? And we are taking three such points on that line segment CD. Okay, 3 such points on the line segment CD. One point is here, another point is here, maybe another point is here. So first one, I'm going to draw R1, P1, Q1 is a triangle. And let me draw in the, suppose in the red color. So it is R1, P1, I'm joining, R2, P2 joining, and let me name it as R1. The second one I'm going to draw in a, suppose in purple color. And here, dear students, so this point is R2, and the line what I'm going to join is that R2, P2, R2, Q2. Then we get the triangle R2, P2, Q2. And the third one, dear students, so let me draw in the this color, yellow color. And here I'm making it is R3. So what it will be, dear students, is that, R3 to P3 and R3 to Q3. So if you see the, the triangles are R1, P1, Q1, R2, P2, Q2, R3, P3, Q3. What is the area of the triangle R1, P1, Q1? So area, let me use a different color. So area of the triangle R1, P1, Q1. Can you tell me what is the area of this one? So half into base, that is
P1
P1,
Q1.
Q1, into the altitude, that is from R1, we can draw a perpendicular, correct? So let me first draw this perpendicular in the black color, the way I did it for the previous one. So from R1, if we draw a perpendicular, it will be like this. Suppose R1, L1, I'll name it. Then from R2, if you draw a perpendicular, it will be something like this. So R2, L2. And from R3, if you draw a perpendicular, it will be something like this. R3, L3. So R1, L1, R2, L2, and R3, L3. Correct, dear students? So then what we are getting, half of P1 into Q1 for the area of the triangle R1, P1, Q1 is half into P1 into Q1 into R1, L1, correct or not? And area of the triangle, all of you are able to get it, dear students? Any difficulty? Please do let me know. R2, P2, Q2 is equal to half into P2 into Q2 into R2, L2. Do you agree to me that that is the area? And area of the triangle
Yes, sir.
R3, P3, Q3, that is equal to half into P3 into Q3 into R3 into L3, correct? So if you look into this, that P1 Q1 equal to P2 Q2 equal to P3 Q3, that is what is called the equal base. And we just observe from the our understanding that R1 L1 equal to R2 L2 equal to R3 L3, because these are the line segment between two parallel lines, so they has to be equal, right? Because R1 L1 is perpendicular to both AB and CD. R2 L2 is perpendicular to both AB and CD, and R3 L3 is perpendicular to both AB and CD. So hence R1 L1 should be equal to R2 L2 equal to R3 L3. So areas of all these triangles, what we see, dear students, are equal. Do you agree to me? Any doubt here? Or absolutely clear, dear students?
Yes, sir.
Okay.
Yes, sir.
So what we get is that all are equal. So areas of all these triangles where they are of equal base and between the same parallels AB and CD are equal. So good, dear students. So we had a very good discussion so far. Now what I'm going to do is that I'm going to solve a problem together. Okay. Now before solving the problem, the converse of that theorem, what we just learned, the converse of the theorem will be what? Two triangles having the same base or equal bases and equal areas must lie between the same parallels. Do you agree to my statement? So, what I'm saying, let me write it down. So, by the way, so there should be equal bases. It should be plural number. So let me write it down. So if there are two triangles, having the same base, or equal bases and equal areas lie between the same parallels. Lie between the parallels. Okay, so that is the converse of the theorem, and this is also true. You can prove it also. Now, I'm going to solve one problem and together, and the problem is that so that the median of a triangle divides it into two triangles of equal areas. It is a very important theorem. It's a very important, not a theorem. It is an important, statement, and we are going to prove it. So, what we are going to prove it, dear students? So let me write it down. That so that a median of a triangle, so that the median of a triangle divides its it into two triangles of equal areas. Okay, is the statement clear to all of you, dear students?
Yes, sir.
Yes, sir.
So,
Yes, sir.
great, thank you. So let us prove it. Okay, let us validate this statement what I just spoke. And to validate it, dear students, what we need to do first, we need to draw our diagram describing the problem statement. That means we should have a triangle, and as you see the triangle, dear students, ABC is the triangle. ABC is the triangle, and ADB one of its medians. Correct. So how come we can say AD is the median? So that's definitely that D is the midpoint of BC. Correct. So what we need to prove? We need to prove that the area of the triangle ABD is equal to area of the triangle ACD. So as I am saying that ADD is the median. So AD is the median. So let me prove it in different color. Okay. Let ABC be the triangle. ABC be the triangle, and AD be one of its medians. So what we need to prove that? We need to prove that area of the triangle ABD is equal to area of the triangle ADC. Correct, dear students? So how to prove it? Now we know the formula of the area of a triangle involves the altitude. So let us draw an altitude AN, that is from the vertex A to the line segment, the base BC. So you see AN is the altitude. That means what we can say, AN is perpendicular to BC. So AN is perpendicular to BC. Now let us find the area of the triangle ABD. Okay, so what is the area of the triangle ABD? Area of the triangle ABD is equal to half into base. What is the base here? Base is the BD. And into altitude, what is the altitude? Altitude is AN. Correct, dear students? Do you agree to me? Whatever I have wrote so far. So this is equal to
Yes, sir.
half into, yeah, thanks. Now we know BD is equal to CD because AD is a median. No? So definitely BD is equal to CD. So instead of BD, we can write half into CD into AN. So in bracket, we can write since that CD is equal to BD. Correct, dear students? Now, if you look into it, half into CD into AN, what is that? That is nothing but half into base into altitude for the triangle A, CD. Correct? So that is equal to area of the triangle ACD. Correct? So what we prove? We prove that area of the triangle ABD is equal to area of the triangle ACD, and it actually confirms the statement what you wrote in the red color, that is, so that the median of a triangle divides it into two triangles of equal areas. Is it clear, dear students? Absolutely. Or any
Yes,
difficulty,
sir.
any smallest question you have? Clear?
Clear, sir.
Okay, great.
Yes, sir.
Now, as it is clear, dear students, so let us proceed for the next question. So in the next question, I'm just going to give you a quadrilateral. Okay, let me first draw the diagram and then explain, and let me take you to the next page. So as you see this diagram, dear students, ABCD is a quadrilateral. Okay, and BE is parallel to AC. Okay, and also BE meets DC produced at E. Okay, so let me write it down. Whatever I just said, let me write it down. So the first statement what I say is that ABCD is a quadrilateral. ABCD is a quadrilaterals. Just a quad. Okay, dear students. So ABCD is a quadrilateral, And the next statement what I'm saying is that BE is parallel to AC. Also, BE meets DC. You see in the adjoining diagram that BE meets DC produced at E. Produced at E. So what you need to prove? We need to prove that area of the triangle ADE is equal to the area of the quadrilateral ABCD. So prove that area of the triangle ADE is equal to area of the quadrilateral ABCD. ABCD. Is the question clear, dear students?
Sir, what is that one there which is next to parallel, that sign?
Are you talking about this one?
Yes, yes, sir.
Okay. So parallel is defined either by this or parallel.
Oh, okay, okay, sir. I didn't know that, sir.
Perpendicular is defined by this or perpendicular. R. It is just like R or perpendicular, parallel L. Both are the same meaning. Okay.
Okay, sir. Yes.
Okay. All right. Now let us concentrate on the question. So what I was telling is that is the question very clearly understood? What you need to prove? You need to prove that
Yes,
area
sir.
of the triangle ADE is equal to area of the quadrilateral ABCD. So if you look into the figure very carefully, dear students, that you will find two triangles. One is BAC and the other one is that EAC. Now BAC and EAC lie on the same base AC, correct? And between the same parallels AC and BE, do you agree to me? What I'm telling about? BAC.
Yes.
Let me draw in a different color. So sorry. The first one is that BAC. So this is one triangle. And another one is that EAC. So let me draw in a different color. EAC. If you see one triangle I draw in green color, the other one is that in purple color. So do you agree to me that areas of these two triangles BAC and EAC are equal? Because they are on the same base AC. They are on the same base AC and between the same parallels AC and B, correct? Do you agree to me, dear students? Absolutely clear?
Yes, sir.
Okay, so I'm
Yes,
going
sir.
to it. Okay. Triangle BAC and triangle EAC are on the same base AC and between the same parallels AC and BE.
So, sir, triangle DAC becomes common for both of them, and that's how we prove it.
Yes, triangle DAC.
DAC.
Yeah, absolutely correct. So from here, what we can say is that area of the triangle BAC is equal to area of the triangle EAC. I hope all of you agree to me. So now what I'm doing is that I am going to add that ADC to both the sides. So that implies what? Area of the triangle BAC. So let me write the triangle sign properly. BAC plus area of the triangle ADC is equal to area of the triangle EAC plus area of the triangle ADC. Now, why I add the area of the triangle ADC both the sides like this? If you add the triangle BAC and ADC, what do you get, dear students? You get the the quadrilateral ABCD, correct or not? And if you add these two triangle EAC and ADC, what you get, dear students?
Triangle DAE.
AD, correct? Sure. That is the reason why we add the area of the triangle ADC to both the sides. So this implies area of the quadrilateral, area of the quadrilateral ABCD is equal to area of the triangle ADE, correct? And that is what we have been given to prove. Absolutely clear, dear students? Any doubt you have, please feel free to ask me. Okay, so what I want to say is that you need to appear one DPP. Once the class is done, I will share the video session of this entire class, whatever we have done today. Please go through the each and every part of this video lecture. Have your idea very clear, and then start appearing the second DPP. For example, if you look into the last problem what we have solved, okay, this one, what you see in front of the screen, apparently it is, when you get this problem, apparently it may look little difficult. Okay, but if you see this, problem in very minutely, and you need to take care of the, other, how we can add the area of the triangle ADC both the sides. Okay, so that we can get, that area of the, we get the area of the quadrilateral and area of the triangle too, so that it is helping us to prove it. What I wanted to mean is that you need to have your, full concentration of the figure, and try to understand how I can reach to the area of the quadrilateral, how I can reach to the area of the, triangle, the given quadrilateral and given triangle, and how we can make a very good hold of it by means of practice, extensive practice. and extensive practice happens with a discipline. And that is why in our online test platform, we have DPP, per DPP 10 questions. Every day you do one, so that if you do one every day over a period of 7 days, it is 70 questions we have solved, and that is a quite a good number. So that is why disciplined approach makes a lot of sense, along with the understanding. So this is all about what I wanted to discuss today.